Question 1. Consider a multinational food processing company that has recently transitioned to ISO 22000-2018. The company's newly established food safety policy emphasizes a zero-tolerance approach to undeclared allergens. During an internal audit, it was discovered that, while the policy was formally documented and approved, several production line supervisors in a key overseas facility were unaware of its specific implications for their daily operational procedures, particularly regarding ingredient traceability and change management. What aspect of the ISO 22000-2018 communication requirements is most likely deficient in this scenario, hindering the effective implementation of the food safety policy? Option A. The organization has failed to identify all external interested parties who need to be informed about the food safety policy, thereby creating potential supply chain vulnerabilities. Option B. The organization has not conducted a comprehensive risk assessment of the food safety policy itself, leading to an oversight in communicating its critical control points. Option C. The organization has not integrated the food safety policy into the broader organizational strategy, making it appear as a standalone document with limited practical relevance. Option D. The organization has not adequately established the necessary communication channels and methods to ensure the food safety policy and its relevant information are understood by all personnel at relevant levels. The correct answer is D. The organization has not adequately established the necessary communication channels and methods to ensure the food safety policy and its relevant information are understood by all personnel at relevant levels. Explanation: the ISO 22000-2018 standard places significant emphasis on effective communication within the food safety management system. Clause 7.4. Communication outlines the requirements for establishing, implementing, and maintaining an effective communication process. This clause is crucial because it ensures that relevant food safety information is shared with internal and external parties, fostering a collective responsibility for food safety. The standard requires the organization to determine the need for internal and external communication related to the food safety management system. This includes specifying what to communicate, when to communicate, with whom to communicate, how to communicate, and who is responsible for communicating. For internal communication, it means ensuring information flows up, down, and across the organization, involving all levels and functions. For external communication, it involves interacting with suppliers, customers, regulatory bodies, and other stakeholders regarding food safety matters. A robust communication plan, as mandated by ISO 22000-2018, directly supports the establishment of the food safety policy and objectives, as these must be understood and implemented throughout the organization. Without clear communication channels and defined responsibilities for sharing the policy, its effectiveness in guiding the organization's food safety efforts would be severely compromised. The policy itself serves as a foundational statement of the organization's commitment to food safety, and its dissemination and understanding are paramount for its successful integration into daily operations and decision-making processes. Therefore, the communication of the policy is not merely an informational task, but a strategic imperative for the functioning of the entire food safety management system. Question 2. Consider a hypothetical food processing facility, Agri-Harvest Solutions, that specializes in the extraction of botanical oils used as natural flavorings in beverages and confectionery. Their operations involve sourcing raw plant materials, performing mechanical pressing, and bottling the final oil product. Agri-Harvest Solutions also operates a small research and development laboratory to explore new extraction methods and to test the stability of their oils. Which of the following best describes the applicability of ISO 22000-2018 to Agri-Harvest Solutions operations? Option A. ISO 22000-2018 is not applicable as Agri-Harvest Solutions only produces ingredients and not finished consumer-ready food products. Option B. ISO 22000-2018 is applicable only to the bottling and distribution aspects of Agri-Harvest Solutions, excluding their extraction and R&D activities. Option C. ISO 22000-2018 is applicable only if Agri-Harvest Solutions is a large-scale producer, and not to organizations with specialized ingredient manufacturing operations. Option D. ISO 22000-2018 is applicable to Agri-Harvest Solutions, because it is involved in the processing and bottling of food ingredients, directly impacting the safety and suitability of final food products. The correct answer is D. ISO 22000-2018 is applicable to agri-harvest solutions because it is involved in the processing and bottling of food ingredients, directly impacting the safety and suitability of final food products. Explanation: the transition to ISO 22000-2018 from previous versions, or the initial implementation, requires a thorough understanding of the standard scope. ISO 22000-2018 defines its scope as applicable to any organization, regardless of size or complexity, that is involved in any aspect of the food chain. This includes organizations that directly or indirectly contribute to the safety and suitability of food products. The food chain encompasses all stages from farm to fork, including primary production, processing, manufacturing, packaging, storage, distribution, retail, and food service. Importantly, the standard also applies to organizations producing ingredients, feed for food-producing animals, and even cleaning and sanitation agents used in food production. The key principle is that any entity whose activities can impact the safety of the food supply chain is within the purview of ISO 22000-2018. This broad scope means that a small artisanal bakery, a large multinational food manufacturer, a farm supplying raw materials, or a catering company all fall under the standard's applicability if they implement it. The standard does not prescribe specific outcomes, but rather a framework for managing food safety, making it adaptable to diverse organizational contexts within the food chain. Question 3. Consider a scenario at Aroma Bites Bakery, where a batch of prepackaged croissants was found to contain a higher than permissible level of a specific preservative, exceeding the limits set by the National Food Safety Authority, Regulation EC, No. 1333/2008 on food additives. The bakery's internal quality control identified this deviation before the products were shipped to retailers. According to ISO 22000-2018 principles for controlling product and process nonconformities, what is the most critical immediate action the bakery must undertake to manage this nonconforming output effectively and comply with food safety regulations? Option A. Immediately discard the entire batch of nonconforming croissants without further investigation to eliminate any potential risk to consumers. Option B. Notify the National Food Safety Authority about the potential issue and await their instructions on how to proceed with the nonconforming batch. Option C. Issue a voluntary recall notice to all retailers that receive the affected batch of croissants, regardless of whether the nonconformity was detected before or after distribution. Option D. Segregate the entire batch of nonconforming croissants and initiate a thorough investigation into the root cause of the preservative excess, documenting all corrective actions taken. The correct answer is D. Segregate the entire batch of nonconforming croissants and initiate a thorough investigation into the root cause of the preservative excess, documenting all corrective actions taken. Explanation: the transition to ISO 22000-2018 requires organizations to establish and maintain processes for controlling product and process nonconformities. When a nonconforming product or process is identified, the organization must take action to control it. This involves determining the nonconformity, its cause, and the required actions to prevent recurrence. ISO 22000-2018, specifically in Clause 8.5.4, outlines the requirements for control of nonconforming outputs. The fundamental principle is to ensure that nonconforming products or processes are identified and controlled to prevent unintended use or delivery. The actions taken can include correction, segregation, recall, or informing relevant parties. The effectiveness of these actions must be verified. The core of managing nonconformities is not just about fixing the immediate issue, but also about understanding the root cause and implementing preventive measures to avoid similar occurrences in the future, thereby strengthening the overall food safety management system. This aligns with the Plan, Do, Check, Act cycle inherent in management system standards. The standard emphasizes segregation of nonconforming products to prevent their entry into the food chain, and if the nonconformity has already occurred, appropriate measures like recall or withdrawal must be initiated. The decision on how to deal with nonconformities must be based on a risk assessment considering the potential impact on food safety and regulatory compliance. Question 4. Considering the stringent requirements for preventing contamination during a transition to ISO 22000-2018, what fundamental aspect of facility construction and layout poses the most significant risk of cross-contamination between raw materials and finished goods if not adequately addressed through segregation and directional flow? Option A. Inadequate separation of raw material receiving areas from finished product packaging zones, leading to potential airborne or contact transfer of contaminants. Option B. The use of non-food grade materials for internal wall surfaces in processing areas, which are difficult to clean and sanitize effectively. Option C. Insufficient lighting levels in critical control points, hindering visual inspection for foreign bodies and sanitation effectiveness. Option D. The presence of external drainage channels that are not adequately sealed, potentially allowing ingress of pests and environmental contaminants into the facility. The correct answer is A. Inadequate separation of raw material receiving areas from finished product packaging zones, leading to potential airborne or contact transfer of contaminants. Explanation: the transition to ISO 22000-2018 necessitates a thorough review and potential redesign of existing food production facilities to align with updated requirements for preventing contamination and ensuring product safety. Clause 8.2.1 of ISO 22000-2018, specifically addressing the construction and layout of buildings, mandates that facilities be designed and maintained to prevent contamination. This includes considering the flow of materials, products, and personnel to minimize cross-contamination risks. Furthermore, the standard emphasizes the importance of appropriate segregation of activities, such as raw material handling from finished product packaging. Utilities, including water supply, ventilation, and waste management, must be designed and maintained to prevent contamination of food. For instance, a facility transitioning from a previous standard might find that its existing raw material intake area, located adjacent to the finished product dispatch zone without adequate physical barriers or directional flow, poses a significant cross-contamination risk. Similarly, ventilation systems that recirculate air from processing areas to storage areas without HEPA filtration could be non-compliant. The question probes the understanding of how these physical aspects of the facility, when not properly managed, can directly contravene the principles of hazard control and prevention of contamination as outlined in the standard, particularly concerning the flow and segregation of operations. The focus is on identifying the most critical aspect of facility design and layout that directly impacts the prevention of cross-contamination, a core tenet of modern food safety management systems. Question 5. Consider a food processing facility that has been operating under a previously certified food safety management system. Upon initiating the transition to ISO 22000-2018, the internal audit team identifies that the existing hazard analysis process, while effective, does not explicitly differentiate between hazards controlled by prerequisite programs, PRP, and those controlled by operational prerequisite programs, OPP, as delineated in the new standard. Additionally, the documentation structure does not clearly map to the high-level structure, HLS, requirements for context of the organization and interested parties. Which of the following actions would be the most critical initial step in addressing these identified gaps to ensure a compliant transition? Option A. Revise the hazard analysis methodology to explicitly categorize control measures according to their designation as PRPs or OPP and restructure documentation to align with the HLS clauses related to organizational context and external/internal issues. Option B. Immediately update the HAC plan to incorporate new critical control points identified through an external risk assessment and train all personnel on the revised critical limits. Option C. Develop a new supplier approval program based on the latest food safety regulations and conduct a comprehensive review of all critical safety parameters for raw materials. Option D. Implement a digital traceability system for all products and enhance the recall procedure to include a simulated mock recall within the next quarter. The correct answer is A. Revise the hazard analysis methodology to explicitly categorize control measures according to their designation as PRPs or OPP and restructure documentation to align with the HLS clauses related to organizational context and external/internal issues. Explanation: The transition to ISO 22000-2018 necessitates a thorough review and update of the existing Food Safety Management System, FSMS, to align with the new high-level structure, HLS, and updated requirements. Clause 10. 3. Improvement specifically mandates that an organization shall continually improve the suitability, adequacy, and effectiveness of the FSMS. For company transitioning from an older standard or implementing ISO 22000-2018 for the first time, this involves identifying gaps between the current system and the new standard's requirements. A key aspect of this transition is the integration of the HLS, which introduces new clauses and a common framework for all management system standards. This integration requires careful consideration of how existing processes and documentation need to be restructured or augmented. For instance, the emphasis on risk-based thinking throughout the standard, particularly in the context of operational prerequisite programs (OPP) and control measures, demands a re-evaluation of hazard analysis and critical control point (HAC) principles within the new framework. Furthermore, the updated requirements for communication, management review, and internal audits must be incorporated, ensuring that the FSMS remains effective in managing food safety throughout the supply chain. The process of continual improvement is iterative, involving the identification of nonconformities, corrective actions, and preventive measures to enhance the FSMS performance and its ability to meet intended food safety outcomes. Question 6. A global food manufacturer transitioning to ISO 22000-2018 is reviewing its risk assessment process. They have identified several potential issues, including a recent increase in regulatory scrutiny regarding allergen labeling in a key export market, and the emergence of a novel processing aid with uncertain long-term stability. The organization's management team is debating the most comprehensive approach to addressing these identified risks and opportunities, as per the standard's requirements for actions to address risks and opportunities. Which of the following actions best reflects the proactive and integrated strategy mandated by ISO 22000-2018 for managing such evolving challenges? Option A. Conduct a one-time review of the HAC plan to incorporate allergen labeling changes and request a certificate of analysis for the processing aid from the supplier. Option B. Delegate the responsibility for managing allergen labeling compliance to the export department and rely on the processing aid supplier's existing safety data sheets for assurance. Option C. Implement a revised allergen detection protocol and initiate a collaborative research project with the supplier of the new processing aid to validate its stability under various storage and processing conditions, documenting all findings and updating the prerequisite programs and HAC plan accordingly. Option D. Update the allergen labeling procedures to comply with the new export market regulations and monitor the supplier's quality control reports for the processing aid without further immediate action. The correct answer is C. Implement a revised allergen detection protocol and initiate a collaborative research project with the supplier of the new processing aid to validate its stability under various storage and processing conditions, documenting all findings and updating the prerequisite programs and HAC plan accordingly. Explanation. The transition to ISO 22000-2018 requires organizations to systematically identify and address risks and opportunities that could affect the conformity of products and services, or the ability to enhance customer satisfaction. Clause 6. One of the standard, actions to address risks and opportunities, mandates that the organization shall determine risks and opportunities related to the food safety management system. This involves considering the issues referred to in 4. 1. Context of the organization and 4. 2. Needs and expectations of interested parties, as well as the requirements of the standard itself. The organization must plan actions to address these risks and opportunities. These actions are integrated into the food safety management system processes, and their effectiveness is evaluated. The standard emphasizes a proactive approach, moving beyond mere hazard control to encompass broader organizational factors that impact food safety. The aim is to prevent undesirable events and achieve intended outcomes, thereby ensuring the overall effectiveness and continual improvement of the food safety management system. This includes anticipating potential disruptions in the supply chain, changes in regulatory landscapes, such as updates to HAC principles or specific national food safety laws, and emerging foodborne pathogens or contaminants. Question 7. When transitioning to ISO 22000-2018, an organization is establishing its approach to monitoring, measurement, analysis, and evaluation, considering the requirements of Clause 9. Which of the following best describes the primary purpose of analyzing data derived from the Food Safety Management System's operational controls and performance indicators? Option A. To provide a basis for benchmarking against competitor performance metrics and achieving the highest possible market share in the food industry. Option B. To generate detailed reports for regulatory bodies, ensuring compliance with all mandated food safety legislation and standards without further interpretation. Option C. To solely document the routine operation of prerequisite programs and critical control points, as per the Hazard Analysis and Critical Control Points (HACP) plan. Option D. To identify trends and patterns that inform decisions on the effectiveness and suitability of food safety controls and the overall system, facilitating proactive adjustments and improvements. Correct answer is D. To identify trends and patterns that inform decisions on the effectiveness and suitability of food safety controls and the overall system, facilitating proactive adjustments and improvements. Explanation. The transition to ISO 22000-2018 requires organizations to systematically monitor, measure, analyze, and evaluate the performance of their food safety management system, FSMS. This process is crucial for demonstrating conformity, ensuring effectiveness, and driving continual improvement. Clause 9, Performance Evaluation, specifically addresses these activities. Monitoring involves ongoing observation of FSMS processes and their outcomes against defined criteria. Measurement quantifies these observations. Analysis involves processing the collected data to identify trends, patterns, and potential deviations from expected performance. Evaluation then assesses the significance of these findings in relation to the organization's food safety objectives and the overall effectiveness of the FSMS. For instance, an organization might monitor the effectiveness of a new pasteurization process by measuring the microbial load of the final product over time. Analysis of this data might reveal a slight upward trend in specific bacterial counts. Evaluation would then determine if this trend poses a risk to food safety, if it requires corrective action, or if the process remains within acceptable limits as defined by regulatory requirements, e.g., limits set by the Food and Drug Administration for specific pathogens, and the organization's own food safety plan. The key is to use these insights to make informed decisions about the FSMS, such as adjusting control measures, retraining personnel, or updating prerequisite programs. This iterative cycle of monitoring, measurement, analysis, and evaluation is fundamental to maintaining and enhancing food safety assurance. Question 8. Following a successful transition to ISO 22000-2018, a food processing facility, AgriHarvest Delights, is focusing on enhancing its food safety management system. To ensure the most effective and systematic approach to continual improvement, what serves as the primary and most direct internal driver for identifying opportunities for enhancement within the newly established framework? Option A. Monitoring of changes in national and international food safety legislation. Option B. Proactive adoption of emerging food safety technologies and automation. Option C. Analysis of internal audit findings and FSMS performance monitoring data. Option D. Response to an increasing volume of customer complaints regarding product traceability. The correct answer is C. Analysis of internal audit findings and FSMS performance monitoring data. Explanation. The transition to ISO 22000-2018 necessitates a robust approach to continual improvement, a core tenet of modern management systems. This involves systematically identifying opportunities for enhancement across all aspects of the food safety management system, FSMS. When considering the primary driver for initiating such improvements post-transition, the standard emphasizes learning from the implemented system. This learning occurs through various mechanisms, including internal audits, management reviews, analysis of monitoring and measurement data, and feedback from stakeholders. These activities collectively provide insights into the FSMS effectiveness, efficiency, and adherence to requirements. The most direct and comprehensive source for identifying systemic weaknesses and potential enhancements, especially after an initial transition, is the performance data and audit findings generated by the newly implemented system itself. These data points reveal where the system is not performing as intended or where more effective controls could be established, directly informing corrective actions and proactive improvements. While external regulatory changes or customer complaints are important inputs, they often represent reactions to existing issues or external pressures rather than the primary internal mechanism for driving proactive FSMS enhancement post-transition. Similarly, technological advancements, while valuable, are typically integrated as a result of identified needs or opportunities for improvement, rather than being the initial impetus for improvement activities following a system transition. Therefore, the analysis of internal FSMS performance data and audit outcomes is the foundational element for driving meaningful continual improvement in the immediate aftermath of an ISO 22018 transition. Question 9. Consider a scenario at a bakery producing artisanal bread where the primary mixing equipment, crucial for dough consistency and yeast activation, is discovered to be vibrating excessively and intermittently failing to reach its set speed during a critical batch. This deviation from its calibrated operational parameters has been ongoing for the past 3 production cycles, and preliminary checks suggest a potential issue with the motor's bearing. If a portion of the dough processed during these cycles has already been baked and packaged, what is the most appropriate immediate action according to the principles of ISO 22018 transition, focusing on the control of nonconformities and preventing unsafe food from reaching consumers? Option A. Document the equipment malfunction in the maintenance log and rely on the standard cleaning procedures to mitigate any potential contamination. Proceeding with the distribution of all packaged products. Option B. Immediately segregate all baked products made from the suspect dough batches and conduct a thorough risk assessment to determine their disposition, while initiating immediate repair and recalibration of the mixing equipment. Option C. Continue production with the faulty equipment, assuming the deviation is minor and unlikely to affect the final product's safety, and schedule maintenance for the next planned downtime. Option D. Halt all production immediately. Dismantle the faulty mixing equipment for extensive repair, and await the completion of the repair before assessing the safety of any previously processed dough or baked goods. The correct answer is B. Immediately segregate all baked products made from the suspect dough batches and conduct a thorough risk assessment to determine their disposition, while initiating immediate repair and recalibration of the mixing equipment. Explanation: the transition to ISO 22018 necessitates a thorough review of existing food safety management system elements, particularly those related to Operational Prerequisites Programs (PRP) and the Hazard Analysis and Critical Control Points (HAC) Plan. Clause 8.5.3 of ISO 22018, Control of Nonconformities, outlines the requirements for managing deviations from established procedures and specifications. When equipment used in a food processing facility, such as a high-speed packaging line, is found to be operating outside its specified parameters, leading to potential contamination risks, e.g., incorrect seal integrity, foreign object ingress, this constitutes a nonconformity. The organization must have a documented procedure to identify, segregate, and evaluate such nonconformities. The disposition of the affected product depends on the nature of the nonconformity and the risk assessment. Options include rework, reprocessing, destruction, or diversion for other uses if safety is assured. The core principle is to prevent unsafe food from reaching the consumer. The ISO 22018 standard emphasizes a risk-based approach, meaning the severity of the nonconformity and its potential impact on food safety dictate the corrective actions and product disposition. Merely documenting the issue without addressing the root cause and ensuring the affected product is handled appropriately would be insufficient. Similarly, assuming the equipment will self-correct without verification is contrary to the standard's intent. While investigating the root cause is crucial, the immediate priority is managing the nonconforming product. Therefore, the most effective approach aligns with the standard's requirement to control nonconformities by evaluating them and taking appropriate action, which includes managing the affected product to prevent potential harm. Question 10. Consider a food processing facility that has identified the potential presence of Listeria monocytogenes in a ready-to-eat product. The hazard analysis indicates a high likelihood of occurrence if specific environmental controls are not maintained. Furthermore, the product is intended for a vulnerable population, An initial assessment suggests that existing general sanitation procedures, e.g., cleaning and sanitizing of equipment, are insufficient to consistently prevent contamination to an acceptable level. Based on the principles of the ISO 22000-2018 decision tree for hazard control, which of the following is the most appropriate conclusion regarding this hazard? Option A. The hazard is deemed acceptable due to the general sanitation procedures in place. Option B. The hazard should be monitored through routine product testing rather than a specific control point. Option C. The hazard can be adequately managed through enhanced prerequisite programs without the need for a CCP. Option D. The hazard requires a critical control point, CCP, to ensure its control to an acceptable level. The correct answer is D. The hazard requires a critical control point, CCP, to ensure its control to an acceptable level. Explanation. The decision tree analysis, as applied within ISO 22000-2018, is a systematic tool to determine the necessity and type of control measures for identified food safety hazards. It guides the user through a series of yes/no questions, starting with whether a hazard is likely to occur and whether it poses an unacceptable risk. If a hazard is likely to occur and poses an unacceptable risk, further questions are asked regarding the effectiveness of existing controls and the potential for new controls. The primary goal is to differentiate between hazards that require specific control measures and those that can be managed through general good hygiene practices or are deemed acceptable. The output of this process informs the CCP determination or the establishment of prerequisite programs. The key principle is that if a hazard is likely to occur and cannot be controlled by prerequisite programs alone, it becomes a candidate for a critical control point, CCP. Conversely, if a hazard is unlikely to occur or can be adequately controlled by prerequisite programs, it typically does not require a CCP. The decision tree facilitates a scientifically sound and documented approach to hazard control, aligning with the HACCP principles and the Integrated Management System requirements of ISO 22000-2018. This structured approach ensures that control measures are targeted and effective, minimizing the risk of foodborne illness and supporting the overall food safety objectives of the organization. The process emphasizes the integration of prerequisite programs and operational control measures to manage identified hazards, ensuring a robust food safety management system. Question 11. Consider a mid-sized food processing company, Agri-Harvest Delights, that is transitioning from its previous food safety certification to ISO 22000-2018. The company's CEO, Mr. Anand Sharma, is tasked with demonstrating genuine leadership and commitment to this transition. Which of the following actions by Mr. Sharma would most effectively signal and embed this commitment within the organization's food safety management system, aligning with the core principles of ISO 22000-2018's leadership clause? Option A. Appointing a dedicated food safety manager and empowering them with the authority to make critical decisions regarding hazard control and corrective actions. Option B. Actively ensuring the food safety management system is integrated into the organization's business processes and allocating the necessary financial and human resources for its successful implementation and ongoing maintenance. Option C. Regularly communicating the importance of food safety objectives and the need for employee participation in food safety training sessions throughout the transition period. Option D. Establishing clear, measurable food safety objectives for each department and ensuring these objectives are documented in the company's strategic plan. The correct answer is B. Actively ensuring the food safety management system is integrated into the organization's business processes and allocating the necessary financial and human resources for its successful implementation and ongoing maintenance. Explanation. The transition to ISO 22000-2018 emphasizes the critical role of leadership in establishing, implementing, maintaining, and continually improving the food safety management system. Clause 5. 1. Leadership and commitment specifically mandates that top management demonstrate leadership and commitment with respect to the food safety management system. This involves ensuring that the food safety policy and objectives are established and that the FSMS is integrated into the organization's business processes. Crucially, it requires ensuring the availability of resources necessary for the FSMS, communicating the importance of effective food safety management and of conforming to the FSMS requirements, and ensuring that the FSMS achieves its intended outcomes. Furthermore, top management must engage, direct, and support persons to contribute to the effectiveness of the FSMS and promote a culture of food safety. And considering the most impactful way for top management to demonstrate this commitment during a transition, it is through actively ensuring the FSMS integration into business processes and the provision of necessary resources. This proactive approach underpins the entire system's effectiveness and sustainability. While communication and engagement are vital, they are often manifestations of the underlying commitment to resource allocation and process integration. Establishing objectives is a foundational step, but demonstrating commitment goes beyond mere establishment to active facilitation. Question 12. Consider a food processing facility transitioning to ISO 22000-2018 that handles both raw poultry and packaged dairy products. During an internal audit focused on the layout of premises, a critical observation was made regarding the proximity of employee changing rooms to the dairy packaging line. The changing rooms are located directly adjacent to the packaging area, with a single door opening into a common corridor that also leads to the dairy packaging line. What specific aspect of the ISO 22000-2018 requirements for the layout of premises is most likely compromised by this arrangement, potentially leading to a nonconformity? Option A. Failure to implement a traceability system for raw ingredients used in the dairy products. Option B. Inadequate segregation of personnel and materials to prevent cross-contamination between raw and processed food zones. Option C. Lack of documented procedures for pest control management in the external perimeter of the facility. Option D. Insufficient provision of adequate lighting and ventilation in the primary processing areas. The correct answer is B. Inadequate segregation of personnel and materials to prevent cross-contamination between raw and processed food zones. Explanation: the transition to ISO 22000-2018 necessitates a thorough review and potential redesign of facility layouts to align with updated requirements for preventing contamination and ensuring segregation of activities. Clause 8.3 of ISO 22000-2018, specifically addressing the layout of premises, including workspace and employee facilities, emphasizes the need for design that facilitates effective food safety management. This includes considering the flow of materials and personnel to prevent cross-contamination, adequate separation of raw and finished products, and the provision of suitable facilities for employees that do not compromise food safety. When evaluating a facility for compliance, auditors will look for evidence that the physical environment supports the food safety management system. This involves examining how the layout prevents ingress of pests, allows for effective cleaning and sanitation, and ensures that different stages of food processing, handling, and storage are appropriately segregated. For instance, a facility that processes both raw meat and ready-to-eat salads would need distinct processing areas, separate equipment, and controlled personnel movement between these zones to prevent the transfer of pathogens. Employee facilities, such as changing rooms and wash basins, must be located and designed to prevent contamination from entering the food processing areas. The design should also consider ventilation, lighting, and waste management systems as integral components of the overall food safety control strategy. The question probes the understanding of how the physical environment, as mandated by ISO 22000-2018, directly impacts the operationalization of the food safety management system, particularly concerning the prevention of cross-contamination and the maintenance of hygienic conditions. Question 13. Consider a food processing facility transitioning to ISO 22000-2018. They are reviewing their hack plan for a ready-to-eat processed meat product, specifically addressing the biological hazard of Listeria monocytogenes *. The current control measure involves a validated thermal processing step. What is the primary metric used to demonstrate the effectiveness of this control measure in reducing the hazard to an acceptable level? Option A. The percentage of finished product samples testing negative for Listeria monocytogenes * over a 6-month period. Option B. The number of supplier corrective actions related to raw material microbial load. Option C. The frequency of internal audits conducted on the thermal processing equipment. Option D. The documented logarithmic reduction achieved by the thermal process for Listeria monocytogenes *. Correct answer is D. The documented logarithmic reduction achieved by the thermal process for Listeria monocytogenes *. Explanation. The transition to ISO 22000-2018 requires a thorough review and potential update of existing hazard analysis and critical control point (HACP) plans, particularly concerning biological hazards. When evaluating the effectiveness of control measures for bacterial contamination, specifically Listeria monocytogenes * in a ready-to-eat processed meat product, the focus must be on the ability of the control measure to reduce the hazard to an acceptable level or prevent its occurrence. The standard emphasizes a risk-based approach. For Listeria monocytogenes *, which can grow at refrigeration temperatures and is often associated with post-processing contamination in ready-to-eat foods, a control measure needs to demonstrate a significant reduction or elimination, a validated thermal processing step that achieves a specific logarithmic reduction, e.g., a 5-log reduction, is a common and effective method. Alternatively, a validated antimicrobial treatment or a critical control point focused on preventing recontamination after a lethal process would be crucial. The concept of acceptable level is defined within the HACP plan, often linked to regulatory limits or internal safety targets. Therefore, control measures' efficacy is measured by its documented ability to meet these predefined safety criteria for the specific hazard. The question probes the understanding of how a control measure's effectiveness is quantified and validated in the context of a food safety management system undergoing transition to the 2018 version of ISO 22000, which places greater emphasis on the integration of HACP principles with the overall management system. Question 14. When transitioning to ISO 22000-2018, a food manufacturer is introducing a novel ingredient, cultured insect protein, into a popular ready-to-eat snack. The hazard evaluation for this new product must be particularly rigorous. Which of the following principles most accurately guides the prioritization of identified food safety hazards associated with this novel ingredient for the development of control measures? Option A. Focusing solely on biological hazards, as these are typically the most prevalent risks associated with insect-derived products, and assigning control measures based on their presence in raw materials. Option B. Prioritizing hazards based on a combined assessment of their likelihood of occurrence and the severity of potential adverse health effects, with special attention to those unique to the novel ingredient's life cycle and processing. Option C. Emphasizing the control of physical hazards, such as insect fragments from the production environment, as these are considered the most significant risks for ready-to-eat snacks, regardless of the primary ingredient. Option D. Assigning control measures primarily based on regulatory requirements for traditional snack ingredients, assuming that the novel insect protein will be subject to similar, well-established control strategies. The correct answer is B. Prioritizing hazards based on a combined assessment of their likelihood of occurrence and the severity of potential adverse health effects, with special attention to those unique to the novel ingredient's life cycle and processing. Explanation. The transition to ISO 22000-2018 necessitates a comprehensive hazard evaluation process. This process involves identifying potential food safety hazards, biological, chemical, physical, and allergenic, that may be reasonably expected to occur in a food chain. For each identified hazard, the organization must determine its likelihood of occurrence and the severity of its potential adverse health effects. The evaluation then categorizes hazards as either controlled by prerequisite programs, PRP, or requiring specific control measures within the HACP plan, often referred to as operational prerequisite programs, OPP, or critical control points, CCP. The key consideration during this evaluation, particularly for a newly introduced ingredient like cultured insect protein in a ready-to-eat snack, is to consider the inherent characteristics of the ingredient itself and its processing. Insect protein, depending on its source and processing, can introduce novel biological hazards, e.g., specific bacterial strains, potential mycotoxins from feed, and allergenicity concerns that might not be present in traditional ingredients. Therefore, a thorough assessment must go beyond generic hazard lists and delve into the specific risks associated with the novel ingredient's life cycle, including its sourcing, farming, harvesting, processing, and potential for cross-contamination during manufacturing. The question probes the understanding of how to prioritize hazards for control measures, emphasizing the need to consider both likelihood and severity in the context of the entire food chain, with particular attention to new or novel ingredients that may present unique risk profiles not fully addressed by existing PRPs. The correct approach involves a systematic assessment that considers the entire food chain, the potential for these hazards to cause illness, and the feasibility of controlling them through defined measures. Question 15. A food processing facility transitioning to ISO 22000-2018 is reviewing its existing food safety objectives. The organization identifies a need to enhance its control over a critical process identified in its hazard analysis, which has historically shown minor fluctuations impacting product quality and potentially posing a low-level risk. According to the requirements for establishing and planning to achieve food safety objectives within the ISO 22000-2018 framework, which of the following represents the most comprehensive and compliant approach? Option A. Define a specific, measurable, achievable, relevant, and time-bound, SMART food safety objective for the identified process, detailing the actions, required resources, responsible parties, and verification methods needed to achieve it, ensuring alignment with the food safety policy and legal requirements. Option B. Establish a general objective to improve overall process efficiency, without directly linking it to specific food safety hazards or measurable outcomes, and rely on the food safety team's general oversight to address any emerging issues. Option C. Focus solely on implementing additional corrective actions whenever deviations occur in the critical process, assuming that reactive measures will eventually lead to objective achievement without prior explicit objective setting or planning. Option D. Update the existing food safety policy to broadly mention the importance of process control and delegate the responsibility of setting specific targets to individual department managers without a formal planning framework. The correct answer is A. Define a specific, measurable, achievable, relevant, and time-bound, SMART, food safety objective for the identified process, detailing the actions, required resources, responsible parties, and verification methods needed to achieve it, ensuring alignment with the food safety policy and legal requirements. Explanation. The transition to ISO 22000-2018 necessitates a reevaluation and potential reformulation of food safety objectives to align with the updated standards requirements. Clause 6. 2. Food safety objectives mandates that an organization shall establish food safety objectives at relevant functions, levels, and processes within the food safety management system. These objectives must be measurable, communicable, monitored, communicated, and updated as appropriate. Furthermore, the standard emphasizes that these objectives should be consistent with the food safety policy and consider applicable legal and regulatory requirements, customer requirements, and the results of hazard analysis and risk assessment. When planning to achieve these objectives, organizations must determine what will be done, what resources will be required, who will be responsible, when it will be completed, and how the results will be evaluated. This involves integrating these actions into the overall management system processes. Considering a scenario where a food manufacturer aims to reduce the incidence of a specific pathogen contamination in their ready-to-eat products, a relevant food safety objective would be to decrease the detected levels of this pathogen below a predefined threshold within a specified time frame. The planning to achieve this would involve identifying the specific processes contributing to the risk, implementing enhanced sanitation protocols, revising critical control point parameters, and conducting more frequent verification testing. The effectiveness of these actions would be evaluated by comparing the pathogen detection results against the established objective. Therefore, the most effective approach to establishing and achieving food safety objectives under ISO 22000-2018 involves a systematic process of defining measurable goals linked to identified hazards and risks, and then meticulously planning the necessary actions, resources, responsibilities, and timelines for their attainment and verification. Question 16. During the transition to ISO 22000-2018, a food processing facility producing chilled, ready-to-eat meals must reevaluate the likelihood of occurrence for Listeria monocytogenes contamination during the final packaging stage. The facility has a history of occasional environmental swabs showing low-level Listeria presence in the immediate vicinity of the packaging line, despite a robust cleaning and sanitation program. Furthermore, the chilled storage temperature for the finished product is maintained at 3/PM1//circ/text-C, a range where Listeria can potentially grow. Considering these factors, which of the following best describes the appropriate assessment of the likelihood of occurrence for Listeria monocytogenes contamination at this stage? Option A. Medium, assuming that the occasional environmental findings are isolated incidents and do not pose a significant risk to the final product. Option B. Low, because the existing cleaning and sanitation program is considered robust and has historically prevented finished product contamination. Option C. Negligible, as the final product undergoes no further lethality step after packaging, making the packaging stage the most critical control point for this hazard. Option D. High, due to the potential for proliferation during chilled storage and documented instances of low-level environmental presence near the critical control point. The correct answer is D. High, due to the potential for proliferation during chilled storage and documented instances of low-level environmental presence near the critical control point. Explanation: the transition to ISO 22000-2018 requires a thorough review and update of the food safety management system, particularly concerning the assessment of hazards and the determination of control measures. The standard emphasizes a risk-based approach, where the likelihood of occurrence of a food safety hazard is a critical component in determining the significance of that hazard. This likelihood is not a static value, but rather a dynamic assessment based on factors such as the frequency of past occurrences, the conditions under which the hazard might arise, and the effectiveness of existing controls. When assessing the likelihood of a specific pathogen, such as Listeria monocytogenes, contaminating a ready-to-eat product during post-processing handling, an organization must consider the inherent characteristics of the pathogen, the process environment, e.g., temperature, humidity, sanitation status, the raw materials used, and the operational procedures in place. For instance, if there have been historical instances of Listeria detection in the processing environment, or if the product is stored at refrigerated temperatures where Listeria can proliferate, the likelihood of occurrence would be considered higher. Conversely, if rigorous sanitation protocols are consistently maintained, and the product is handled in a highly controlled environment with minimal human contact, the likelihood might be assessed as lower. The standard encourages a systematic approach to this assessment, often using a matrix or scoring system to categorize the likelihood, which then informs the selection and implementation of appropriate prerequisite programs and HACCP control measures. The ultimate goal is to prevent or reduce to acceptable levels the presence of hazards that could cause harm to consumers. Question 17. A food processing facility specializing in ready-to-eat meals is transitioning to ISO 22000-2018. They have identified Listeria monocytogenes as a critical hazard in their cooked chicken component. While regulatory guidelines permit a certain level of this pathogen in specific food categories, the company's internal risk assessment, considering the extended shelf life of their products and the presence of potentially vulnerable consumer groups, suggests a more stringent internal limit. Additionally, a key export market has its own specific, even lower, tolerance for Listeria monocytogenes in imported processed foods. Considering these factors, what is the most appropriate basis for establishing the acceptable level of Listeria monocytogenes in the end product for this facility under ISO 22000-2018? Option A. The lowest limit specified by any relevant regulation, customer specification, or internal risk assessment, provided it is scientifically achievable and verifiable. Option B. The limit determined solely by the company's internal risk assessment, prioritizing consumer health above all other considerations. Option C. The limit stipulated by the National Regulatory Authority, as this is the minimum legal requirement for all food products. Option D. The limit specified by the most prominent export market, as this ensures compliance with the most demanding international standard. Correct answer is A. The lowest limit specified by any relevant regulation, customer specification, or internal risk assessment, provided it is scientifically achievable and verifiable. Explanation: the transition to ISO 22000-2018 requires organizations to reevaluate their hazard analysis and control strategies, particularly concerning acceptable levels of hazards in end products. ISO 22000-2018 emphasizes a risk-based approach, integrating the Codex Alimentarius general principles of food hygiene and HACCP principles. When determining acceptable levels of hazards in end products, an organization must consider various factors beyond just the intrinsic properties of the hazard itself. These include relevant legislative and regulatory requirements, which set legally binding limits for many contaminants and pathogens. Furthermore, customer specifications and contractual agreements often dictate stricter limits than those mandated by law. The organization's own food safety policy and its risk assessment outcomes are paramount, ensuring that the chosen acceptable levels are scientifically justifiable and aligned with the overall food safety objectives. The potential impact on consumer health, considering vulnerable populations, must also be a primary consideration. The effectiveness and reliability of the monitoring and verification methods used to ensure these levels are met are also crucial. Therefore, a comprehensive approach that synthesizes regulatory compliance, customer expectations, internal risk assessment, and public health considerations is essential for establishing appropriate and defensible acceptable levels of hazards in end products. The concept of as low as reasonably practicable, ALARP, is often implicitly applied, but the specific acceptable level must be a defined, measurable value. Question 18. Following an internal audit that revealed recurring instances of improper temperature control during the chilling phase of poultry processing, a food manufacturing company, Aviary Delights, must update its corrective action procedures as part of its ISO 22018 transition. The audit report highlighted that the root cause analysis often focused on immediate operational errors rather than systemic issues within the cooling system's maintenance schedule or staff training protocols. Which of the following approaches best aligns with the ISO 22018 requirements for corrective actions in this scenario, focusing on preventing recurrence and demonstrating system effectiveness? Option A. Document the nonconformity. Retrain the specific staff members involved in the temperature deviations, and file the audit report without further action until a similar issue is reported. Option B. Implement a revised standard operating procedure for chilling. Conduct immediate retraining for all processing staff on temperature monitoring, and schedule a one-time inspection of all refrigeration units within 1 month. Option C. Conduct a comprehensive root cause analysis to identify systemic failures in equipment calibration, maintenance schedules, and the adequacy of training on HACCP principles related to chilling. Then implement and verify corrective actions addressing these identified systemic issues. Option D. Increase the frequency of external audits specifically targeting temperature control, relying on external auditors to identify and rectify the underlying causes of the nonconformities. The correct answer is B. Implement a revised standard operating procedure for chilling, conduct immediate retraining for all processing staff on temperature monitoring, and schedule a one-time inspection of all refrigeration units within 1 month. Explanation. The transition to ISO 22018 necessitates a thorough review and potential revision of existing corrective action procedures. ISO 22018 emphasizes a proactive approach to food safety, moving beyond simple identification of nonconformities to understanding their root causes and preventing recurrence. When a nonconforming product is identified, the organization must take immediate control measures to prevent its distribution. Following this, a systematic investigation into the root cause of the nonconformity is crucial. This investigation should consider the entire food chain and all relevant prerequisite programs and operational prerequisite programs. The corrective action plan should then be developed and implemented to eliminate the identified cause. This plan should include actions to prevent recurrence, which might involve changes to procedures, training, equipment, or the food safety management system itself. The effectiveness of these corrective actions must be verified and documented. Furthermore, the organization needs to review the effectiveness of its entire corrective action process to identify opportunities for improvement, ensuring that the system remains robust and adaptable to new or evolving food safety risks. This cyclical process of identification, investigation, action, and verification is fundamental to maintaining and enhancing food safety. Question 19. During the transition to ISO 22018, a food manufacturer specializing in ready-to-eat meals identifies that their existing critical limit for cooling time of a cooked product, set at 2 hours to reach below /10/Circ C/, needs re-evaluation. This reevaluation is prompted by new research indicating that a specific spoilage organism, while not an immediate safety hazard, can proliferate significantly within this time frame, impacting product shelf life and consumer acceptance, and potentially indicating a breakdown in the control of other, more critical, hazards. The manufacturer must now establish a new critical limit that not only addresses the original food safety hazard, but also considers this emerging information and the enhanced focus on risk-based thinking in the 2018 standard. Which of the following represents the most appropriate approach for establishing this revised critical limit? Option A. Adjust the critical limit for cooling time to a more conservative value, such as 1. 5 hours to reach below /10 /circ based on the new research and a precautionary principle, ensuring the limit is scientifically validated for both safety and quality aspects. Option B. Increase the critical limit for cooling time to 5 hours to reach below /10 /circ to allow for greater flexibility in the cooling process, assuming the spoilage organism's growth is not a direct safety concern according to current regulatory guidelines. Option C. Remove the cooling time from the list of critical control points entirely, as the primary safety hazard is already controlled by the cooking step, and focus only on the spoilage organism as a quality parameter managed through good manufacturing practices. Option D. Maintain the existing critical limit of 2 hours to reach below /10 /circ as it was originally established to control a significant safety hazard, and address the spoilage organism through a separate operational prerequisite program. The correct answer is A. Adjust the critical limit for cooling time to a more conservative value, such as 1. 5 hours to reach below /10 /circ based on the new research and a precautionary principle, ensuring the limit is scientifically validated for both safety and quality aspects. Explanation. The transition to ISO 22000-2018 requires a thorough review and potential adjustment of established critical limits within a food safety management system. Critical limits are defined as specific criteria that separate a normal condition from an unacceptable one. They are based on scientific evidence and regulatory requirements, and their purpose is to ensure that a control measure effectively controls a food safety hazard. When establishing or revising critical limits, an organization must consider the scientific rationale behind them, the specific food product, the processing conditions, and relevant legal standards, such as those set by the Food and Drug Administration, FDA, or equivalent international bodies. For instance, if a critical control point, CCP, involves thermal processing to eliminate a specific pathogen, the critical limit for time and temperature must be scientifically validated to ensure pathogen lethality, while also being practically achievable within the processing equipment. The transition to the 2018 version, with its emphasis on risk-based thinking and the integration of the Annex SL structure, necessitates a re-evaluation of how these critical limits are identified, documented, and monitored, ensuring they remain robust and aligned with the updated framework's principles. The focus is on ensuring that the chosen limits are demonstrably effective in preventing or reducing a food safety hazard to an acceptable level, as per the hazard analysis. Question 20. Consider a facility producing aged artisanal cheeses. During the hazard analysis for their ISO 22000-2018 transition, the team identified several potential control points for microbial contamination. They are deliberating whether a specific aging temperature control aimed at inhibiting undesirable microbial growth should be designated as a critical control point, CCP, or an operational prerequisite program, OPP. If the aging process itself is crucial for developing the desired flavor profile, but the primary hazard of concern, such as the proliferation of Listeria monocytogenes can also be effectively managed through stringent sanitation protocols and raw material testing as OPP. What is the most appropriate determination for the aging temperature control in the HACCP plan according to ISO 22000-2018 principles? Option A. Designate the aging temperature control as an OPP, provided that the sanitation and raw material testing are robust and demonstrably reduce the risk to an acceptable level. Option B. Designate the aging temperature control as a CCP, irrespective of other control measures, to ensure maximum control over potential microbial proliferation during aging. Option C. Reevaluate the hazard analysis to identify a more significant hazard that would necessitate the aging temperature control as a CCP, potentially overlooking the current primary concern. Option D. Classify the aging temperature control as a prerequisite program, PRP, because it is a general condition for production rather than a specific control measure for a particular hazard. The correct answer is A. Designate the aging temperature control as an OPUP, provided that the sanitation and raw material testing are robust and demonstrably reduce the risk to an acceptable level. Explanation: the transition to ISO 22000-2018 mandates a thorough review and update of existing prerequisite programs, PRP, and operational prerequisite programs, OPUP, to align with the revised framework. When establishing the HACCP plan, particularly for a complex product like artisanal cheese where multiple critical control points, CCP, might be identified, the organization must ensure that the CCPs are correctly identified and that their critical limits are scientifically valid and measurable. The hazard analysis process, a cornerstone of HACCP, involves identifying biological, chemical, and physical hazards associated with the food product and its production process. For artisanal cheese, potential biological hazards include Listeria monocytogenes and Salmonella, while chemical hazards might involve cleaning agents or allergens. Physical hazards could be foreign objects like glass or metal. The determination of control measures for these hazards, and subsequently their classification as CCPs or OPUP, requires a systematic approach. A CCP is a step where control can be applied and is essential to prevent or eliminate a food safety hazard or reduce it to an acceptable level. OPUP are control measures that are necessary to ensure that the food safety hazards and the degree of contamination are controlled to an acceptable level. The critical limits for each CCP must be established based on scientific evidence and regulatory requirements, such as those outlined by the Food and Drug Administration, FDA, for dairy products, which often specify pasteurization temperatures and holding times. For instance, if pasteurization is identified as a CCP for controlling Listeria monocytogenes, the critical limit might be a specific temperature-time combination, e.g., /72/circ/text-c/ for 15 seconds. Monitoring these critical limits involves regular checks and measurements. The validation of the HACCP plan ensures that the plan is capable of controlling the identified hazards effectively. This validation should consider the scientific principles and regulatory standards applicable to the specific food product and its processing. The transition to ISO 22000-2018 emphasizes a risk-based thinking approach, meaning that the identification and management of hazards should be proportionate to the level of risk. Therefore, when selecting control measures, an organization must consider their effectiveness in reducing the hazard to an acceptable level, the feasibility of implementing and monitoring them, and their alignment with the overall food safety objectives. The question focuses on the critical step of ensuring that the identified CCPs are indeed the most appropriate, and that their associated critical limits are robust and defensible, which is a core requirement for an effective HACCP plan under the ISO 22000-2018 standard. Question 21. When transitioning to ISO 22000-2018, an organization specializing in processed fruit and vegetable products is reassessing its production facility's construction and layout. The existing facility has a single entry point for both raw produce and packaging materials, and the ventilation system draws air from the finished product packaging area into the raw ingredient processing zone. What is the most critical aspect of the facility's physical environment that requires immediate attention to align with the principles of ISO 22000-2018, considering the potential for cross-contamination? Option A. Installing a new, high-capacity refrigeration unit for the finished goods warehouse to accommodate increased production volumes. Option B. Upgrading the lighting intensity in the quality control laboratory to meet the minimum lux requirements specified in local food safety regulations. Option C. Implementing a more frequent cleaning schedule for all production equipment, regardless of the facility's layout issues. Option D. Ensuring adequate segregation of raw material receiving, processing, packaging, and finished goods storage areas to prevent the transfer of biological and chemical contaminants. The correct answer is D. Ensuring adequate segregation of raw material receiving, processing, packaging, and finished goods storage areas to prevent the transfer of biological and chemical contaminants. Explanation: the transition to ISO 22000-2018 necessitates a thorough review and potential upgrade of the physical environment where food is handled. Clause 8.3 of the standard, concerning the control of outsourced processes, monitoring and measurement, analysis and evaluation and improvement, implicitly requires that the facility's design and layout support the implementation of food safety controls. Specifically, the layout must prevent cross-contamination between raw materials, intermediate products, and finished goods, and also between different food categories if multiple products are processed. Utilities, such as water supply, ventilation, and waste disposal systems, must be designed and maintained to prevent contamination of food and food contact surfaces. For instance, HVAC systems should ensure adequate air changes and filtration to minimize airborne contaminants and prevent backflow. Water systems must be potable and protected from contamination. Waste management areas should be located and designed to prevent pest attraction and the spread of pathogens. The standard emphasizes a risk-based approach, meaning the specific design and utility requirements will be determined by the types of food being processed, the processes involved, and the identified hazards. Therefore, the primary consideration for construction and layout in the context of ISO 22000-2018 transition is the effective management of risks associated with the physical environment to prevent contamination. This involves ensuring segregation of activities, appropriate materials of construction, and reliable utility systems that do not introduce hazards. The goal is to create an environment that inherently supports food safety, rather than relying solely on procedural controls to mitigate environmental risks. Question 22. A food processing facility, transitioning to ISO 22000-2018, discovers a batch of prepackaged salads that were inadvertently filled with a higher concentration of a permitted preservative than specified in their validated formulation. This deviation was identified during internal quality checks before the product was released for distribution. Considering the requirements of ISO 22000-2018, what is the most appropriate initial action for the organization to take regarding this non-conforming product batch to effectively manage the food safety risk? Option A. Immediately segregate the affected batch and conduct a thorough risk assessment to determine the extent of the deviation and its potential impact on consumer safety, retaining all related documentation. Option B. Dispose of the entire batch without further investigation to avoid any potential legal ramifications or consumer complaints. Option C. Expedite the distribution of the batch to clear inventory, while simultaneously initiating a corrective action process for future production runs. Option D. Notify regulatory authorities immediately and await their guidance before taking any action on the non-conforming product. The correct answer is A. Immediately segregate the affected batch and conduct a thorough risk assessment to determine the extent of the deviation and its potential impact on consumer safety, retaining all related documentation. Explanation: the transition to ISO 22000-2018 requires organizations to reevaluate their operational planning and control measures in light of the updated standard's emphasis on risk-based thinking and integration with other management system standards. Clause 8.5.2 of ISO 22000-2018, Control of Nonconformities, specifically addresses the actions to be taken when a nonconformity occurs in the food safety management system. This includes identifying and controlling nonconforming outputs to prevent unintended use or delivery. The standard mandates that the organization shall take action to eliminate the detected nonconformity or, where this is not possible, to prevent its recurrence. Crucially, the organization must also take action to deal with the consequences of the nonconformity, which may involve segregation, containment, or destruction of the affected product. Furthermore, the standard requires the organization to retain documented information regarding the nonconformity and the actions taken. This systematic approach ensures that potential risks associated with nonconforming products are managed, thereby safeguarding consumer health and maintaining the integrity of the food safety system. The primary goal is to ensure that any deviation from planned food safety requirements is effectively managed to prevent adverse impacts on food safety. Question 23. A food manufacturer specializing in ready-to-eat chilled meals is transitioning to ISO 22000-2018. During the hazard identification phase for a new product line featuring marinated chicken and a creamy sauce, the team is reviewing potential hazards. Beyond the obvious microbiological risks from raw chicken and potential allergen cross-contamination from shared processing lines, what other critical aspect of hazard identification, often overlooked in basic hazard analysis, must be thoroughly investigated according to the principles of ISO 22000-2018 for this specific product? Option A. The risk of chemical contamination from cleaning agents used on the shared processing lines. Option B. The possibility of foreign object contamination from the packaging machinery, such as small plastic fragments. Option C. The potential for Listeria monocytogenes proliferation in the creamy sauce due to its pH and water activity, considering the chilling and distribution temperature abuse scenarios. Option D. The likelihood of consumer misinterpretation of cooking instructions leading to undercooking of the chicken. The correct answer is C. The potential for Listeria monocytogenes proliferation in the creamy sauce due to its pH and water activity, considering the chilling and distribution temperature abuse scenarios. Explanation: the transition to ISO 22000-2018 necessitates a thorough hazard identification process that goes beyond merely listing potential biological, chemical, and physical agents. It requires a systematic approach to understanding how these hazards can enter the food chain, persist, or proliferate at each stage of the food production process. This involves considering not only the raw materials and ingredients, but also the processing aids, packaging materials, and environmental factors. Furthermore, the standard emphasizes the importance of understanding the intended use of the food product and the potential misuse by consumers, which can introduce new or amplify existing hazards. A key aspect of this comprehensive identification is the integration of knowledge about the specific food product, its composition, its processing methods, and its intended market. For instance, identifying allergens requires a deep understanding of ingredient sourcing and potential cross-contamination points throughout the manufacturing process, including storage and handling. Similarly, identifying chemical hazards might involve reviewing the approved list of food additives, processing aids, and their permitted levels, as well as considering potential contaminants from equipment or packaging. The effectiveness of hazard identification is directly linked to the robustness of the hazard analysis, which forms the foundation of the entire food safety management system. This process should be dynamic, incorporating feedback from production, quality control, and even customer complaints to ensure continuous improvement and adaptation to evolving food safety landscapes. Question 24. A food processing company transitioning from an older food safety standard to ISO 22000-2018 is reviewing its existing prerequisite programs. They have a program for general facility cleaning and pest control, which they previously categorized as standard prerequisite programs. During their hazard analysis, they identified a significant risk of cross-contamination from a specific airborne microorganism in a critical production zone for ready-to-eat meals. To mitigate this, they are implementing a more rigorous, documented, and monitored air filtration and environmental monitoring system for this zone, including specific corrective actions for deviations. Which of the following best describes the appropriate reclassification or designation for this enhanced control measure within the ISO 22000-2018 framework? Option A. Maintain the existing classification as a standard prerequisite program, PRP, as it relates to general facility hygiene. Option B. Classify it as part of the Food Safety Management System, FSMS, documentation without a specific operational designation. Option C. Designate the control measure as a critical control point, CCP, because it involves monitoring and corrective actions. Option D. Reclassify the Enhanced Air Filtration and Environmental Monitoring System as an operational prerequisite program, OPP, due to its direct role in controlling an identified food safety hazard. The correct answer is D. Reclassify the Enhanced Air Filtration and Environmental Monitoring System as an operational prerequisite program, OPP, due to its direct role in controlling an identified food safety hazard. Explanation: the transition to ISO 22000-2018 necessitates a thorough review and potential reclassification of existing prerequisite programs, PRP, and operational prerequisite programs, OPP. OPP are control measures that are necessary to prevent or reduce the likelihood of introducing a food safety hazard to the product or product processing environment, and that are appropriate to the intended use of the product. They are distinguished from PRPs in that they are specifically identified through hazard analysis as being necessary to control food safety hazards. For example, a PRP might be general sanitation of a facility, whereas an OPAP might be a specific temperature monitoring protocol for a cooling process, identified as critical for controlling a specific pathogen. The key differentiator is the direct link to an identified hazard and the necessity of the control measure to manage that hazard. Therefore, a control measure that was previously considered a standard PRP, but is now identified through hazard analysis as essential for controlling a specific, significant food safety hazard, such as controlling Listeria monocytogenes in a ready-to-eat product processing area through strict environmental monitoring and corrective actions, would be reclassified as an OPAP. This reclassification ensures that the control measure receives the appropriate level of management, monitoring, and verification as stipulated by the standard for OPAP. Question 25. Consider a food manufacturing facility transitioning to ISO 22000-2018, which previously operated under a less formal quality system. The facility produces a range of baked goods, including those containing common allergens like nuts and gluten. A critical piece of equipment, a multi-purpose dough mixer, has been in use for over a decade. During an internal audit, it was noted that the mixer's internal seals are showing signs of wear, creating small crevices where dough residue can accumulate, and the motor housing, while externally cleanable, is not designed for easy disassembly for deep cleaning. The facility's current cleaning procedure for this mixer is a daily external wash and a weekly internal rinse. What is the most appropriate approach to address the suitability of this dough mixer within the framework of ISO 22000-2018's requirements for equipment control and transition? Option A. Immediately implement a more frequent internal rinse cycle for the dough mixer, in addition to the existing daily external wash, to mitigate any potential residue buildup in the worn seals. Option B. Conduct a comprehensive risk assessment to determine the potential for allergen and microbial cross-contamination due to the worn seals and difficult-to-clean areas, and based on the findings, either modify the mixer to improve cleanability, dedicate it to non-allergenic products, or replace it if the risk cannot be adequately controlled through enhanced cleaning and maintenance protocols. Option C. Update the maintenance log to reflect the worn seals and schedule a general service for the mixer within the next 6 months to address the issue during routine upkeep. Option D. Document the mixer's current condition in the equipment register and rely on the existing cleaning procedures, assuming that the daily external wash is sufficient to maintain food safety standards. The correct answer is B. Conduct a comprehensive risk assessment to determine the potential for allergen and microbial cross-contamination due to the worn seals and difficult-to-clean areas, and based on the findings, either modify the mixer to improve cleanability, dedicate it to non-allergenic products, or replace it if the risk cannot be adequately controlled through enhanced cleaning and maintenance protocols. Explanation. The transition to ISO 22000-2018 mandates a thorough review of existing food safety management system components, including equipment. Clause 8.5.4 Control of nonconforming outputs, and Clause 8.5.1 Control of production and service provision are particularly relevant when assessing equipment suitability for a food processing environment, especially during a transition from an older standard or an informal system. The focus must be on preventing contamination and ensuring operational reliability. Equipment must be designed and constructed to facilitate effective cleaning and maintenance, preventing the accumulation of food residues, allergens, or microbial growth. This involves considering the materials of construction, e.g., food-grade stainless steel, the absence of crevices, the ease of disassembly for thorough cleaning, and the suitability of the equipment's intended use in relation to the specific food products being processed. For instance, a high-speed slicer used for processing allergenic products would require rigorous cleaning protocols and potentially dedicated equipment or effective segregation to prevent cross-contamination, as mandated by allergen management principles within the standard. Maintenance schedules must be documented and followed to ensure equipment continues to operate as intended and does not pose a food safety risk. The suitability assessment should also consider the equipment's ability to maintain critical control points, CCP, or operational prerequisite programs, OPAP within specified limits. Therefore, The most comprehensive approach to ensuring equipment suitability under ISO 22000-2018, particularly during a transition, involves a proactive evaluation of its design, materials, maintenance history, and operational performance against the specific food safety requirements of the products and processes. This evaluation informs the development or refinement of cleaning procedures and maintenance schedules to mitigate identified risks. Question 26. When undertaking a transition to ISO 22000-2018, an organization that produces ready-to-eat meals must ensure its management of purchased materials adequately addresses the standards requirements for controlling externally provided products and services. Considering the complexity of a ready-to-eat meal supply chain, which strategy for managing purchased materials would best align with the principles of ISO 22000-2018, focusing on proactive risk mitigation and supplier accountability? Option A. Implementing a reactive approach where purchased materials are only inspected and tested after a customer complaint or a nonconformity is detected in the finished product. Option B. Primarily relying on supplier self-declarations of compliance with food safety standards and conducting only occasional visual inspections of incoming raw ingredients to ensure basic quality. Option C. Focusing solely on price competitiveness when selecting suppliers, with minimal emphasis on their food safety practices or the intrinsic safety of the materials they provide. Option D. Establishing a robust supplier qualification program that includes rigorous initial and ongoing evaluation of suppliers based on their food safety management capabilities, clearly defined material specifications communicated to suppliers, and a risk-based verification plan for incoming materials. The correct answer is D. Establishing a robust supplier qualification program that includes rigorous initial and ongoing evaluation of suppliers based on their food safety management capabilities, clearly defined material specifications communicated to suppliers, and a risk-based verification plan for incoming materials. Explanation: the transition to ISO 22000-2018 necessitates a thorough reevaluation of how purchased materials are managed to ensure they align with the updated standards requirements. Specifically, Clause 7.4.2 of ISO 22000-2018, Control of Externally Provided Processes, Products, and Services, emphasizes the organization's responsibility to ensure that externally provided products and services that can affect food safety are controlled. This control extends to the identification and documentation of suppliers, the establishment of criteria for their selection, evaluation, and reevaluation, and the communication of requirements to them. When considering the management of purchased materials, the core principle is to ensure that these materials do not introduce hazards or compromise the safety of the final food product. This involves defining clear specifications for all incoming materials, including raw ingredients, packaging, and processing aids. The organization must establish a system for verifying that purchased materials conform to these specifications. This verification process should be based on a risk assessment of the material and its supplier. For materials identified as critical to food safety, a more rigorous verification process, such as incoming inspection and testing, might be required. The selection and evaluation of suppliers should be based on their ability to consistently provide materials that meet the organization's food safety requirements. This evaluation might include reviewing supplier quality systems, conducting audits, or analyzing historical performance data. The standard also requires that the organization communicate its specific food safety requirements to its suppliers, including any relevant regulatory requirements or customer specifications. This ensures that suppliers understand their role in maintaining food safety. Therefore, the most effective approach to managing purchased materials during a transition to ISO 22000-2018 involves a comprehensive system that integrates supplier evaluation, material specification, verification processes, and clear communication of food safety expectations. This approach ensures that the entire supply chain contributes to the overall food safety of the finished product. Question 27. A mid-sized bakery, Golden Crusts, is undergoing its transition to ISO 22000-2018. The company has identified several critical control points in its bread-making process, including the baking temperature and the metal detection stage. During a review of their documented procedures for the transition, It was noted that while the overall responsibility for food safety was assigned to the quality manager, the day-to-day operational oversight and decision-making authority for deviations at the baking temperature (CCP) were unclear, with multiple supervisors having overlapping, but not fully defined, authority. Which of the following best reflects the deficiency in fulfilling the requirements of ISO 22000-2018 concerning organizational roles, responsibilities, and authorities during this transition phase? Option A. Inadequate training for the designated food safety team leader on the principles of HACCP. Option B. Failure to conduct a comprehensive risk assessment for all potential biological hazards in the bakery's products. Option C. Insufficient establishment of prerequisite programs, which are foundational to CCP control. Option D. Lack of clearly defined and communicated authority for operational decisions at a critical control point, potentially undermining the effectiveness of the food safety management system. Correct answer is D. Lack of clearly defined and communicated authority for operational decisions at critical control point, potentially undermining the effectiveness of the food safety management system. Explanation. The transition to ISO 22000-2018 necessitates a clear definition of roles, responsibilities, and authorities within the organization to ensure effective implementation and maintenance of the food safety management system. Clause 5.3 of ISO 22000-2018, Organizational Roles, Responsibilities, and Authorities, mandates that top management shall ensure that responsibilities and authorities for relevant roles are assigned, communicated, and understood. This includes defining who is accountable for food safety, who oversees the food safety management system, and who has the authority to initiate actions to prevent, control, or eliminate food safety hazards. For a food processing company transitioning to the 2018 version, a critical aspect is ensuring that the designated food safety team leader possesses the necessary competence, which encompasses education, training, experience, and a comprehensive understanding of food safety principles, HACCP, prerequisite programs, and the specific food safety management system in place. This individual is often the linchpin for coordinating hazard analysis, establishing control measures, and managing the overall food safety framework. Without this defined leadership and clear delegation of duties, the systematic approach required by ISO 22000-2018 can falter, leading to inconsistencies in hazard identification, control measure implementation, and overall system effectiveness. Therefore, assigning these duties to an individual with demonstrable competence in food safety management is paramount for successful transition and ongoing compliance. Question 28. During a transition audit for ISO 22000-2018, an auditor notes that the food processing facility, Aroma Bites Limited, has retained numerous legacy documents from its previous ISO 22000-2005 certification. These include detailed batch production records, supplier approval forms, and internal audit reports, all of which are still actively used and maintained. However, the auditor also observes that some newer documents, such as the updated HACCP plan incorporating prerequisite programs and a revised management review procedure, are not explicitly referenced or integrated into the overarching document control system. Considering the requirements of ISO 22000-2018 for documented information, which of the following best describes the critical deficiency identified by the auditor regarding Aroma Bites Limited's document management? Option A. The organization has an excessive volume of documented information, leading to inefficiency and making it difficult to identify critical food safety controls. Option B. The organization has failed to adequately update its documented information to reflect the revised requirements of ISO 22000-2018, particularly concerning the integration of prerequisite programs and the management review process, despite maintaining operational records. Option C. The organization has prioritized the creation of new documents over the maintenance of essential operational records, indicating a lack of commitment to core food safety practices. Option D. The organization has not implemented a robust system for the retention of historical records, which is a key requirement for demonstrating continuous improvement. Correct answer is B. The organization has failed to adequately update its documented information to reflect the revised requirements of ISO 22000-2018, particularly concerning the integration of prerequisite programs and the management review process, despite maintaining operational records. Explanation: the transition to ISO 22000-2018 requires organizations to update their documented information to align with the new standards requirements. Clause 7.5.1 of ISO 22000-2018 specifies that the Food Safety Management System shall include documented information required by the standard and documented information determined by the organization as necessary for the effectiveness of the food safety management system. Furthermore, the scope of documented information can include records and documents. Records are evidence that an activity has been performed or results that have been achieved, and they need to be controlled to ensure they are legible, identifiable, and retrievable. Documents, on the other hand, are information intended to be communicated and used, such as policies, procedures, and work instructions. When transitioning, an organization must review all existing documented information to determine its continued relevance and necessity under the new standard. This involves assessing whether existing documents meet the enhanced requirements for hazard analysis, risk-based thinking, and the integration of the Plan-Do-Check-Act cycle, as well as ensuring that the terminology and structure of the standard are reflected. The decision on what documented information to retain, modify, or create is driven by the organization's specific context, its food safety policy, objectives, and the identified hazards and risks associated with its food products and processes. The key is to maintain documented information that effectively supports the operational control of food safety and demonstrates compliance with the standard. Question 29. An established food processing company, Veridian Foods, is transitioning to ISO 22000-2018. Their current traceability system tracks finished goods by production date and a general batch number assigned to a full day's production run. Upon reviewing Clause 8.3 of the standard, which mandates the ability to trace products through all stages of the food chain, Veridian Foods realizes their system might not be granular enough to meet the requirements for rapid and full identification of product in the event of a serious nonconformity originating from a specific raw material lot used across multiple production days. Considering the principles of ISO 22000-2018, what aspect of their traceability system requires the most significant enhancement to comply with the standard's intent for effective recall management? Option A. Expanding the scope of their hazard analysis to include more detailed information on potential cross-contamination points. Option B. Developing a more sophisticated customer relationship management system to track end consumer complaints. Option C. Increasing the frequency of internal audits to ensure adherence to existing traceability procedures. Option D. Implementing unique identifiers for each incoming raw material lot and linking these to specific production batches, enabling a backward and forward trace. Correct answer is D. Implementing unique identifiers for each incoming raw material lot and linking these to specific production batches, enabling a backward and forward trace. Explanation: the transition to ISO 22000-2018 necessitates a review and potential enhancement of existing traceability systems. ISO 22000-2018, specifically in Clause 8.3, requires an organization to establish and maintain a system for tracing food products. This system must enable the identification of product batches and their relationship to production and delivery records. The objective is to facilitate rapid and full identification of product in case of serious nonconformity, allowing for effective recall or withdrawal. When considering the transition, an organization must assess its current traceability capabilities against these requirements. This involves evaluating the granularity of tracking, e.g., batch, lot, or individual item, the speed and accuracy of information retrieval, and the ability to link upstream suppliers with downstream customers. A robust system will typically involve unique identifiers for raw materials, intermediate products, and finished goods, coupled with comprehensive record keeping that captures the flow of these items through the production process and distribution chain. The effectiveness of a traceability system is often tested through mock recalls, which simulate a real-world event to verify the system's ability to quickly and accurately identify affected products and their locations. Therefore, the core of the transition's impact on traceability lies in ensuring the system's capability to provide rapid and complete identification of product history and movement to support food safety incident management. Question 30. An audit of a bakery's transition to ISO 22000-2018 reveals that while robust prerequisite programs are in place to prevent foreign object contamination, a specific risk assessment indicates a low but significant likelihood of small plastic fragments entering the dough during a particular mixing stage due to aging equipment. The bakery currently relies on visual inspection by line operators at the packaging stage as its primary control. Which of the following strategies best aligns with the ISO 22000-2018 framework for managing this identified physical hazard? Option A. Implement a dedicated op-up for monitoring the condition of the aging mixing equipment and conducting periodic calibration checks, alongside enhanced operator training on visual inspection protocols. Option B. Focus solely on replacing the aging mixing equipment immediately to eliminate the source of the potential contamination, considering this a corrective action for the audit finding. Option C. Introduce a new metal detector specifically calibrated to detect plastic fragments at the final product stage to serve as a CCP. Option D. Designate the visual inspection at the packaging stage as a critical control point, CCP, with strict limits for plastic fragments, requiring continuous monitoring and record keeping. The correct answer is A. Implement a dedicated op-up for monitoring the condition of the aging mixing equipment and conducting periodic calibration checks, alongside enhanced operator training on visual inspection protocols. Explanation: the transition to ISO 22000-2018 necessitates a thorough review and potential update of the hazard analysis and critical control points (HAC) plan, particularly concerning the identification and control of physical hazards. Physical hazards, such as glass shards, metal fragments, or plastic pieces, can enter the food product at various stages of the production process. ISO 22000-2018 emphasizes a risk-based approach, requiring organizations to establish, implement, maintain, and continually improve a food safety management system. When considering physical hazards, the standard expects a systematic approach to identify potential sources of contamination and implement effective control measures. This involves not only identifying the hazard itself, but also assessing the likelihood and severity of its occurrence and its potential impact on consumer health. The prerequisite programs, PRP, play a crucial role in preventing the introduction of physical hazards, but the HAC plan, specifically the CCPs and op-up, provides the critical control points for managing residual risks. For instance, a metal detector at the end of a processing line might be a CCP if the risk assessment indicates it is essential to prevent a specific metal contamination. However, if the risk assessment shows that the primary control for glass is through strict equipment maintenance and visual inspections by trained personnel, and these controls are effective and verified, then the focus shifts to ensuring the robustness of these procedural controls, rather than solely relying on a single detection point. The updated standard's emphasis on the interaction between PRPs and the HAC plan means that controls embedded within PRPs can be considered as part of the overall hazard control strategy. Therefore, the most effective approach to managing physical hazards under ISO 22000-2018 involves a comprehensive hazard analysis that considers all potential sources, the effectiveness of PRPs in preventing introduction, and the necessity of specific control points, CCP or op-up, to manage unavoidable or residual risks, often supported by verification activities.